Hello students, I hope you have understood the last class sections about Laplace transform. If any doubt in that, do ask me. Today we are going to look into some other Laplace forms and we will prove the sum of the Laplace forms today. So let's start with the new Laplace forms. So first one, to prove L of t raised to n equal to n factorial by s raised to n plus 1. We know that Laplace form, general equation of the Laplace form, L of f of t equal to integral 0 to infinity e raised to minus st f of t dt. Here f of t equal to t raised to n. So therefore L of t raised to n equal to integral 0 to infinity e raised to minus st into t raised to n dt. That can be called as equation 1. Here we put s of t equal to u. So t equal to u by s, and by taking derivative s of dt equal to du, and from this we can written as dt equal to 1 by s du. Then we change the limit at t equal to 0, u equal to 0, and t equal to infinity, u equal to infinity. Now we have to substitute these values in equation 1. So equation 1 becomes L of t raised to n equal to L of u by s all raised to n, because we already written as t equal to u by s, equal to integral 0 to infinity e raised to minus u by s all raised to n into 1 by s du. Then we can written as integral 0 to infinity 1 by s raised to n plus 1 into e raised to minus u into u raised to n du equal to 1 by s raised to n plus 1. We can take it as outside the bracket integral 0 to infinity e raised to minus u into n plus 1 no into minus 1 du. That can be called as equation 2. We studied that gamma function, gamma n can be written as integral 0 to infinity raised to minus x raised to n minus 1 dx. By comparing this gamma function into equation 2, we can see that here x can be replaced by u, that is integral 0 to infinity raised to minus u into n plus 1 minus 1 du equal to gamma n plus 1. That is equation 2 becomes L of t raised to n equal to 1 by s raised to n plus 1 into gamma of n plus 1. That is gamma n plus 1 equal to n factorial by s raised to n plus 1. Now we have to move to another one. Prove that L of sine of 80 equal to a by s squared plus a squared. Here the function f of t equal to sine 80. So L of sine 80 equal to integral 0 to infinity e raised to minus st into sine 80 dt. That is general formula of Laplace transform. Here function of f of t equal to sine 80. So sine 80 can be written as e raised to i80 minus e raised to minus i80 by 2i. Substitute this value in equation 1 becomes integral 0 to infinity e raised to i80 minus e raised to minus i80 by 2i into e raised to minus st dt. Then by mathematical step expanding, we get 1 by 2i into integral 0 to infinity e raised to i80 into e raised to minus st dt minus integral 0 to infinity e raised to minus i80 into e raised to minus st dt. Then we know that a raised to m into a raised to n equal to a raised to m plus n. So e raised to i80 into e raised to minus e raised to i80 into e raised to minus st can be written as e raised to minus of s minus ia into t, and e raised to minus i80 into e raised to minus st can be written as e raised to of minus s plus ia into t. So by taking integral, so 1 by 2i into e raised to minus I s minus ia into t by minus s minus ia minus of e raised to minus s plus ia by minus of s plus ia, and by applying limit we can get that 1 by 2i equal to 0 minus 1 by minus of s minus ia minus 0 minus 1 by minus of s plus ia. So by applying limit we can get that final expression is that equal to a by s squared plus a squared. So we got that Laplace transform of sin a t can be written as a by s squared plus a squared. These are simple mathematical steps which you have learned in your lower classes. So please refresh your memories and go through these steps. You can easily prove the Laplace transform of these forms. So we proved the Laplace transform of sin a t. Now we are going to prove the hyperbolic function of sin a t. When we look on to the steps, we can see that the only difference is in the denominator. We can see that in sin a t we written as e raised to iat minus e raised to minus iat by 2i. In hyperbolic function of sin a t, there is e raised to at minus e raised to minus at by 2, and by mathematical steps we get that last a by s squared minus a squared. Now you have two homework problems. First one is Laplace transform of cos h at, that is hyperbolic function of cos at, and another one is Laplace transform of cos at.